Hello and welcome to Unstress. My name is Dr. Ron Ehrlich. Now, before I start, I would like to acknowledge the traditional custodians of the land on which I am recording this podcast, the Gadigal people of the Eora Nation, and pay my respects to their elders, past, present, and emerging. We have so much to learn about connection and respect of both people and country from our First Nations people. Well, today we are going to be exploring the topic of ageing, and that is one thing I know we all have in common as we listen to this. We are literally aging as I speak, but how we age is the big question. My guest today is Greg Macpherson. Now, Greg is co-founder of the Wellness Access Institute. He's a founder, futurist, author, biotechnologist, and pharmacologist. Greg co-founded the Wellness Access Institute about 2 years ago, and he's a serial entrepreneur, Greg, as he's also the founder of SRW Labs and Pharmacy Direct Limited, and they are all working in this anti-aging area. I hope you enjoy this conversation I had with Greg Macpherson. Welcome to the show, Greg.
Ron, great to be here. Thank you.
Greg, aging, it's a big topic. Without wishing to offend anyone, as far as I know, it's still the best alternative. You've introduced, or you haven't, but the term maybe has been introduced to the lexicon about Healthspan. How does lifespan and how does Healthspan differ from lifespan?
Yeah, definitely. Great question. I mean, lifespan is an average, right? It's an average of how long we all live on the planet. So average around the world's around 79, which is a great number because it's just increasing all the time. But our health span is actually more important. That's the amount of time we spend healthy on the planet, and that number's a little bit lower. It's around 63. So quite not a long time really. When you think about actually spending time on the planet healthy.
Wow. So okay. Although we are average lifespan 79, it's 16 years difference. People whose that is interesting. How do we define health span?
Yeah, it's just absence of disease, really. It's feeling healthy and energetic, and it's just one of these unfortunate things. We're actually doing incredibly well in terms of building our lifespan, but we're actually spending less of that time in good health, if you will. So the next frontier really is how do we get the health span and push that much further up the calendar.
So that means globally, people would enjoy good health up until, on the average, 63 years of age. Yeah. That is quite sobering.
It's confronting, and I always compare it because, we've got 3 children, and you think that they're going to leave home around 18. Well, you hope they might, but actually they leave home around 13. They move to their rooms and kind of just come and visit you for tea time, right? So it's just this number of health span sneaks up on you way faster than you think. And you can do lots of things about it to, improve your chances of being healthier for much longer. But on average, that's the number.
Well, I know that you've identified 9 hallmarks of aging, and I wanted to discuss some of those with you, and particularly how we might measure them. I'm guessing this is a measure. This is how we came up with the number 63 of years of age, and how we assess progress. One of those is mitochondrial health and energy production, which is part of, that is life there in a nutshell. How do we measure that?
So the hallmarks, just for your audience, are areas that drive cellular aging, and there were recently 9, but recently increased up to 12.
Okay.
So these are constantly being developed and understood, and essentially what they are, like I said, key drivers of aging in our cells, and you measure them simply in a lab where you might accelerate mitochondrial dysfunction, for example, and that results in accelerated aging. But if you do the opposite and you actually improve mitochondrial function, you slow the aging process down. So for mitochondria, it's actually a measurement of the amount of energy it's producing, which is a particular chemical called ATP. But beyond the measurement, it's actually how we feel, right? The level of energy that we're experiencing. And our mitochondria decline in function around 10% a decade from our 40s. So if you imagine us as I guess a V8 engine, if you will, by the time you're 60 or 70, maybe 3 or 4 of those cylinders aren't working properly and aren't delivering energy to your cells. And that's important because your cells have their main thing to do, which might be heart beating or brain thinking or whatever. But our cells also need energy for repair and maintenance and taking the rubbish out and doing the housekeeping. And as that energy declines, those sorts of things get compromised, and that actually starts to impact the health of our cells.
I mean, I think people will be becoming familiar with mitochondrial function and health, but what are some of the things that, I mean, they're probably all the things we're told we shouldn't be doing, but and that's why we're doing them. Why the problem is, I guess. Remind us of what causes mitochondrial dysfunction.
Yeah, so it's actually just a general decline in our batteries, if you will. So that's fundamentally what's causing it. But if we don't exercise, then our mitochondria get themselves tied up in knots. If we eat too much sugar, they do the same thing sorts of happens. Mitochondria take the air we breathe and the food we eat and burn it to create energy. And if we put too much sugar into the mix, it's almost like, back in the old days, you'd flood your engine, so to speak, in terms of just the fuel mixture being too rich. And it, in our case with mitochondria, when we put too much sugar into the system, it puts them under pressure. They start to produce too many free radicals, and those free radicals start to damage our cells. And, you get by with the occasional treat, but if it happens regularly and you have, a poor diet on a continuous basis, then absolutely what you're doing is you're damaging those mitochondria, and ultimately you're damaging your cells.
I mean, given the epidemic of preventable chronic degenerative diseases that we hear so much about and are constantly reminded of, I mean, this is so fundamental to every disease we have, isn't it? Really,
it is, and I think these diseases are actually the next frontier, if you will, of what we need to solve. And it's really where all the aging research is going, is actually starting to understand how do we slow aging at a cellular level so that we slow the onset of some of these diseases that we're going to encounter as we get older. And that really is the crux of why there's so much effort going into these hallmarks of aging, to understand how we can slow it down. Because, these diseases we know, like Parkinson's and Alzheimer's and cardiovascular disease and so on, they're starting to believe they're merely syndromes of cellular aging. So, if we can tap the brakes on that process and slow it down, then, we can actually potentially, back to the Healthspan, start to actually really push that number forward and up.
Another hallmark is intercellular communication. Can you just talk to us a little bit about that?
Yeah, we've got this internet of our body, right? This wonderful machine that just talks with itself, it senses itself, it's understanding the environment, it's sending messages all around the body all the time. And so one of the most common, intercellular communicational messages is inflammation. And that's actually starting at, basically communicating what's happening when you've got perhaps a sore hand, or you've got inflammation in parts of your body. These are actually molecular messages and messengers that are being sent around the body. There are other things as well, like just nerve transmissions through our brain to our body and our cells. It's another way of looking at it. And intercellular communication becomes compromised as we get older. And so this starts to, again, compromise our cells, our organs, our health. And, you can see with inflammation that it might start in one part of your body, but it can actually move throughout your body to different areas and impact parts of your body that you weren't expecting. And so just understanding that gives you, I guess, a really good reason to start to work out, how do we manage that intercellular communication? How do we slow or modulate that inflammation so that we can age healthier?
Another one is DNA, because I know when we talk about cancer, the focus of research and treatment really has been to say it's DNA. It's a genetic problem, unless of course you're a smoker. If you're a smoker, then it seems that there's an environmental issue. But when people get a diagnosis of cancer, most doctors will say to them, "Oh, it's just bad luck and DNA." What is this? That's another hallmark. Healthy DNA. How do we look at that? How do we assess that?
Yeah. So your DNA is this incredible living sensing molecule, which is doing an incredible thing. It's essentially reading the environment almost inside and outside of us and responding by creating the pathways to make various molecules in our bodies that we need. So, for example, if our blood pressure is a little high, there's going to be a mechanism in there which the DNA uses to actually create molecules which help keep your pressure at the right temperature, at the right level, and so on. So it's really quite clever. There's three elements of DNA associated with aging. Something called telomere shortening, which is the caps of your DNA. These caps shorten as we get older and as our cells divide. And you really want long telomeres because shorter telomeres are associated with poorer health outcomes. The next one is called just DNA stability. And so it's incredible, but our DNA breaks something like 100,000 times a day per cell in our body, which is nothing to worry about because we've got incredible repair and maintenance systems that manage that and look after us. But eventually, if you scratch something enough or you break something enough, it doesn't repair properly. And that's when you've got a chance that your DNA is going to start to cause you an issue. And just like you talked about smoking, I mean, smoking essentially accelerates that process. And the more times you damage your DNA, the more chance you've got of something like cancer happening. And then the last thing is something really interesting called epigenetic variation. And it's almost like you've got a base layer of information on your DNA, and then you've got the next layer above it. And that next layer above it is actually what turns on and off your genes. And it's a really, really fascinating, really complex system. But really what it means is you can actually control what genes are expressed. That means how your body acts. And it turns out all these things you do that are really good for you, like going for a walk or a run, eating well, these actually are really positive in terms of supporting those positive genes and keeping you healthy. So if you can focus on being healthy, you're actually caring and nurturing your DNA.
No, I think the science of epigenetics is a really exciting one. Rather than being a victim to your genes, you actually have a control over how they express themselves. We did a wonderful episode with one of my all-time heroes, Bruce Lipton, who wrote The Biology of Belief, and he talked a lot about our control over how genes express themselves.
It's absolutely incredible. I think even those folk that meditate, for example, actually have longer telomeres. So the mind over matter is absolutely a thing.
And we can lengthen our telomeres?
Yeah, absolutely. So again, doing those healthy things we talked about, diet and exercise. Mm-hmm. Vitamin D is really good. Meditation. So yeah, this is what's so exciting. I think about what we're learning is that we've got the power to actually really have a positive impact on how well we age. And it comes down to diet and exercise. It's how positive we age has an effect. Sleep, and then that wonderful thing of stress. And it's not stress; it's just how we manage the stress. The key thing.
Well, I know that Bruce talked about thoughts being things, which are neurotransmitters actually, which attach onto cell membranes and cause them to express themselves one way or another, and I think controlling our thoughts is a powerful tool.
Yeah, there's a great story of one of the monks that's associated with the Dalai Lama, and they tested his blood levels of stem cells before and after meditation, and I believe after meditation the numbers were something like 40% higher. So there is a real net benefit to some of the activities associated with proactively looking after your health.
Stem cells is another one, isn't it? That a hallmark of aging. What is that? Is stem cells with us our whole life? What's the cycle of stem cells through our life as we age?
Yeah, they are with us throughout our life, but they do get the hallmark is called stem cell fatigue. these cells, they're like bank accounts, and we're just taking little bits of money out of those bank accounts all the time as we get older. Stem cells are cells that can pretty much be any cell in our body, more or less. And as our cells wear out, our body dips into those banks and gets fresh new cells, and they eventually run out, and they become less. But that's ultimately what stem cells are doing for us. And I'm excited for the future around stem cells, because it's looking like we can perhaps create a stem cell bank outside of our body at some point, and that'll mean that we can go back in and perhaps borrow a few from the external bank and top up what's going on in our body, and that's going to give us, I think, some significant opportunity to potentially slow that, extend that health span again.
What's like you're almost like a blood bank, a stem cell
Exactly.
bank. Is that actually, that's a very ethically a controversial one though, isn't it? Or is it? I don't,
Well, it's I guess it's just new, and there are stem cell banks that I'm aware of in America where you can deposit stem cells, and with the view that when you need them later in life, that you can use them.
So it is just your own stem cells deposited in a bank for future, not borrowing from someone else's stem cells. I mean, that would be really weird, wouldn't it?
Yeah, well, it's happening as well, but if it was me, I'd be banking my own.
Right. Okay. And is stem cells, do they harvest those from bone marrow? Is that, or where do we get stem cells from in our body?
They're actually in different parts of our body. So there are little satellite cells, which are muscle stem cells, and they hang out in our muscles. And I think our follicles up here, there are certain stem cells as well. I've got a little less than you, but yes, there are stem cells in our bone marrow and various other niches in the body as well.
You're talking about cells, and there's of course turnover of cells, which is really important. And there's this sort of two processes that go on, isn't? Or there's probably a lot more, but autophagy, and apoptosis. Can you just share with us what the difference is between those two and what we mean by cell turnover?
Yeah, absolutely. So apoptosis is essentially cell suicide, and that happens when a cell decides to, remove itself from our body for the greater good, if you will. So it could be simply because it's finished its job. It could be that something's gone wrong, like maybe a touch of cancer, and it's decided that it's better off to remove itself. And so it's just essentially a process where the cell kind of puts its hand up and says, it's time for me to move on, and attracts the immune system to remove it, if you will. And then you've got autophagy, and that's, again, it's called self-eating, and it's a wonderful process. It's like a cell that is not perhaps running as well as it could. It could be that some of the components aren't working as well as they could. And again, it just puts its hand up and says, right, it's time for me to be recycled and be refreshed. And so autophagy is something that happens regularly, but it's a really important process because essentially it gives you a bit of a house clean. And a lot of people will fast, perhaps not eat for a certain amount of time, whether it's half a day or even a few days, which helps trigger autophagy. Exercise does the same. And it's sort of part of from what I understand, part of a longevity pathway where the body, if it doesn't access nutrition or food, that the body takes the slowest and the most compromised cells and uses that for nutrition first. And then when you refeed or you start to eat again, then the body recycles that into fresh new cells, and you get essentially a house clean. And that has huge benefits in terms of health span.
So interesting, isn't it, that fasting has been around for thousands of years, either intentional or not, but intentional fasting has been around since, for literally thousands of years, and it's such a part of so many different cultures. They probably never really understood the cellular nature of it, but there it is.
Yeah, and I think it's a part of the challenge with the Western diet right now is that we actually never get the opportunity to be hungry. And so we don't have the opportunity to trigger autophagy and have that house cleaning. So I think in the age of abundance, it's actually not too harmful occasionally, under doctor supervision, of course, but to spend some time hungry, because it does trigger a lot of pathways which are shown to have significant benefit for our health.
And I guess the key there is that it's cells that are weak or defective that are the ones that are first to go.
Yes, it's an incredible system, and whoever thought it up was pretty smart. But it's the fact that the body recognizes the cells that are compromised and takes them out to recycle and then get refreshed ahead of fully functional cells it's remarkable.
Another hallmark that you've mentioned in your list of 9, or you said now 12, is healthy proteostasis, or maintaining adequate protein, which I know is a big issue in our society at the best, like for a whole range of reasons. What tell us about healthy proteostasis or adequate? Tell us about healthy proteostasis.
Proteostasis is really just keeping your proteins the same, is kind of roughly what that means. And our proteins, a lot of people think about muscle when they think about protein, but just about every molecular machine inside your cell is a protein. And they are absolutely remarkable gadgets, if you will. We talked about that mitochondria earlier, and there's a particular molecule we talked about called ATP, which is the energy chemical of our bodies. Well, there's a protein which spins at like thousands of times a minute to manufacture that, and it's like almost like a turbine that you might see in a hydro station in terms of the water coming through and spinning it and creating energy. But these little molecular machines break down, things chip off, and the body needs to identify those and then replace them. And so proteostasis is essentially a network of processes which identify that and the proteins that are breaking down and replacing them fresh and new. And as we age, again, like everything, unfortunately, that process gets compromised. And when you have a protein that either not working properly and is not removed, or it's been rebuilt but not quite correctly, again, this is when we start to have issues with cellular health, which can manifest in disease and other health issues.
I know there's also an issue about quantity of protein intake, because I know a year or 2 or 3 or 5 ago, it was suggested that the adequate protein intake was 0.8 of a gram per kilogram, or I always thought of it as 1 gram per kilogram because I did the maths a lot easier. And now it's, like it could be 1.6 or 2 grams per kilogram of weight. That's really upping the need for protein as we get older, isn't it?
Yeah, it's really hard work. You've really got to work hard to get the adequate protein in. But for anybody over the age of 50, it's super important because we lose muscle mass. And every decade it's more. And the more muscle mass you have, the more protected you are for all sorts of things, from just even falls, for example, because, if you've got more muscle mass, you're actually more stable. But generally, you just need that muscle mass to be metabolically active, to functionally, I guess, operate as best you can. So that's a key element for anybody over the age of 50 that they need to focus on.
And I mean, given the importance of adequate protein intake, and given the emergence of plant-based, or what I prefer to call ultra-processed foods and vegan diet, this creates a real challenge, not just for health, but for aging as well, doesn't it?
It does. It's a really significant risk factor for the older adults, and so yes, anybody who is wanting to, I guess, be a successful ager really needs to be mindful of the level of protein that they intake, and sometimes that conflicts when we talk about fasting as well. Like, okay, how am I supposed to get the protein? And you're meant to fast and do a little bit of stimulate autophagy. But what's really interesting is that you might fast and you will stimulate your autophagy, but within days, once you refeed, that protein builds straight back up again. So you don't need to worry about it, but and you can do both. They're not mutually exclusive, but very much into your 50s and beyond, a real focus on protein is going to serve you well.
I know we did a program just a few weeks or months ago with a pediatrician from America, Dr. Alyssa Song, a brilliant pediatrician, and she made the point that the challenge was that if you were getting your protein, say, from something like lentils, you would have to be eating a big serve of lentils at every meal, like a full bowl of lentils at least at every meal, 7 days a week. So that's quite a challenge.
It is, and we've just. I know I like to go back to the fact that we're ancient, modern humans with ancient biology, and we've been omnivores and we've eaten meat and we've done all these things for the longest time, and really it's only been the last 100 years that we've started to think outside the box, if you will, and really I don't think you should steer too far away from looking back to see what we used to do, to take the guidance of what we should be doing right now. So certainly there may have been populations that lentils was the main thing, but for most of us, I don't think so. And so, a balanced diet is the best diet.
Yeah, no, couldn't. Music to my ears, Greg, and our regular listeners would know that's certainly the case. You mentioned, well, here we have just sort of gone through 9 hallmarks, and yet you mentioned there was more. What are some of the other ones that I've missed out on?
Certainly. So there's something called dysbiosis, and this relates to just our tummies and the amount of the diversity of bacteria inside our gut. Turns out that we get less and less diversity as we age, and that again compromises us. There are certain bacteria that manufacture fatty acids that are really useful for our lowering inflammation and for brain health. So, making sure that our microbiome is continues to be as diverse is really important as we age. Chronic inflammation is actually the other one, which is actually a split off from the intercellular communication. But we have more and more inflammation as we age. This relates a lot to these things called zombie cells, which are cells that start to build up in our body, and again, perfectly natural when we're young, but as we get older, they build up and cause inflammation and problems. And then the last one is something called macro autophagy. So again, we talked about autophagy, but macro is really just a much wider descriptor of the processes associated with not just autophagy in terms of components of our cells, the full cell.
Because I know that, we think of 11 body systems, and those 11 body systems, things like immune, muscle, skeletal, reproductive, nervous, endocrine, etc., you've added a 12th one, and I think the reason for that is pretty obvious, and I think a really good one. You've added the cellular system. Just give us a little bit of what the thinking there was. What prompted that addition? Seems pretty obvious, really, from this.
Yeah, well, it's a great question because it's actually obvious but not obvious. But, we're made up of cells, and they all are interconnected. And actually, if we look after our cells fundamentally, that is actually the core to good health. So all of our philosophy is, how do we help you have better cellular health? And the downstream benefits of that affect every single other system, if you will. So it's almost like a single target to focus on. And then what we have is other products which support issues when you have a weakness of whatever it might be, whether it's a cardiovascular issue or a gut issue or a neurological issue. But ultimately the score on the door is how well are your cells? And if you can answer and get a good score on that, then you're in good shape.
Right, and using those 12 markers gives us an indication of how healthy your cells are. I mean, this raises a really fundamental question about, do you think supplements are an important part of that journey. You know, you mentioned ancestral habits and learning from that, and that's a subject we've explored many times on this podcast. But the issue of supplements is an interesting one, isn't it? How do we justify the use of supplements?
It's a really, I love that question, because I want to say that, I think with your audience, you will have explored lifestyle and you will have explored diet and exercise, and these are fundamental areas that we need to take responsibility for so that we are healthy. But what we're learning now is that there are certain enzymes and compounds in our bodies that decline as we age, and we're still working out why that is. But fundamentally, there are things like taurine, which is an amino acid. It declines as we age, improves when you exercise. You can get it from diet, but it's correlated with Healthspan decline. And if you've got less taurine in your system, you're going to encounter frailty earlier, if you will. And the best example is the living lab that we're all in. And Japan has a diet which is something like 9 times richer in taurine than the Western diet. And these good people have less cardiovascular disease, less cancer. They just appear to be healthier and live longer than many of us. And that's just one example. Another one is a little molecule called NAD. It's a molecule which is the most abundant molecule in our bodies after water, and it declines as we age. From our 40s, it steps down. And researchers have discovered this. They've played with it in terms of topping it up, and they find that it rejuvenates cells, tissues, organs, and health. Another molecule called AKG, which is a bit of a mouthful, but alpha-ketoglutarate. Again, these are molecules that are, I'm going to say, not new to science, but we're learning that they decline in levels as we age, and it appears when we top them up that they have health benefits. So maybe if you and I had this conversation 10 years ago, I would have said, foundational 5 of lifestyle, sleep, exercise, sleep, mindfulness, and being social is all you need. But we know more now, and the researchers who are really digging into this are starting to find that there are now, it's almost unequivocal that we top up these components, that we will get health benefits.
I mean, one of the challenges is that we live in an environment that challenges us. I mean, we've got soils that are depleted. We've got environmental toxins that deplete us. So it's not really a level playing field anymore, is it? When people say all you need is food. And, I think you do need good food, no question.
Yeah, definitely. No, you're absolutely right. The best food is the organic food. And again, that was a learning for me. Again, the beautiful thing about life is these things that just open up and you start to understand it. But, it's all these, the immune system of all these plants is based on the stress and challenges. And when we give them nice pesticides and we make life very easy for them, they don't need to make this nutrition. And we don't make that nutrition ourselves because we didn't need to, because it was in our diet. But now we're deficient in it, and our diet is deficient in it. So yeah, we do again need to allow for that with any supplement regime that we've got. I strongly think too, in the next 50 years, 100 years, when the people that come ahead of us, or after us, if you will look at us and just think how that we're as crazy as the Victorians used to tip the effluent out of their windows onto the streets in terms of what we're doing to the planet.
Yes.
The level of what we're doing, and all going well, we'll get a lot better at it, and hopefully very soon.
I'm intrigued by the selection of one amino acid out of, there are 20 or 22, 20 or 22, I forget, but to select that one is really interesting. Taurine, I know you made the point about Japanese diet, but yeah.
Yeah, I think there's just so much more to learn. There's an amino acid called methionine, and that is something that also appears to potentially accelerate aging. And if you have a methionine restricted diet, which is quite often that would be a meat restricted diet, which again is counterintuitive to what we're talking about, but it may have some positive impact. But there's just so many areas that interplay here, that we're just having to, I guess, unpack, one at a time. And at the moment, the taurine really hit the news last year through the various studies across yeast and worm and mice models, and even primate models, showing that topic up is particularly good for us.
And the glutarate, is that different from glutamine? Is that the same? Is that a different compound? Because is that a precursor to a glutathione?
Yes.
That whole story there?
Yeah. Actually, you've got me on that one. I haven't spent much time looking at it, but
that's okay. That's okay. Yeah. Not a problem. But I mean, I know NAD is a big one, particularly when we talk about mitochondrial function. That's a big function part there.
Yeah, NAD I think is involved in 300, 400, 500 different enzymatic processes in our body. It's a cofactor in mitochondrial energy production. It's a cofactor with these wonderful proteins called sirtuins that look after our DNA and have other positive effects. And so, these proteins require NAD to operate, and you do want plenty of NAD in your system. And what is also very interesting with NAD is that as we get older, there's less of the stuff produced, but we also increase a level of an enzyme called CD38, and CD38 consumes NAD, and you have more of it when you're overweight. So a strategy for people who are looking to boost NAD in their 40s and 50s might be to take a precursor. But for someone in their 50s or 60s and 70s who perhaps have got a little bit more body weight, then an equally clever strategy is actually to take a little molecule called apigenin, which is something that comes from, parsley and celery, but it's a natural way to actually inhibit that enzyme. So not only are you supplementing by putting a bit more NAD into your system with the precursors, you're actually closing the back door and not chewing through as much by supplementing with that particular natural ingredient.
I mean, I think what you're just talking about gives us an insight into the complexity of the interactions that go on in every cell in our body every second of our lives. I always think that if we had a choice of what we should go back and study, biochemistry and physiology would be an absolute must and starting point, and makes you realize why the prescription pad is so appealing to so many physicians.
Yeah. I'm incredibly excited about the future because of the work that's been doing and the gains that are being made, and the area that I see as being the most having the most potential essentially are these biological aging clocks, right? We've got a particular clock on our DNA which seems to just tick away on all of us, and it delivers us a biological age. And I can be 55 and have a biological age of 65 or 45, depending on how well I'm traveling through time. And it looks like we may be able to reset that clock. And when we do that, it could be that we have a biological age that is 45, and every 10 years we might be able to go back and reset it a little bit. And when you reset it, your cells actually start acting younger and behaving younger. So that to me, if that particular area of research comes to fruition, it's going to give us all an opportunity to go well beyond what we can do right now with just good lifestyle and supplements, but actually potentially get your finger on the dial and start to wind things back a bit and do that regularly. If and when, and I believe that's a fairly high chance that's what we're going to be able to do, that all of us are going to be able to live a lot healthier for a lot longer.
Well, I know your company is focused on that. Tell us a little bit about that company, because I notice you have quite an advisory board there, and one of those members is Dr. Ross Walker, who is not only an old school friend of mine, not only my own cardiologist, but is also a regular guest on my podcast every year to remind people about heart health and the latest in medicine. Tell us about the company and what prompted it.
Yeah, Ross is one of the smartest people I know. He's a great guy.
He is.
So I started the company. I've been involved in biotech for getting close to 15 years, Ron. And the first part of that was all around mitochondria, which is where we started the conversation, and understanding the importance of these little molecular machines in terms of how our bodies operate. And around 5 years ago, I guess I looked up. I stopped looking just at mitochondria and thought, wait a second, we can take a car in for a service, and if just the motor gets sorted, we've got a bit of a problem because the brakes might not work or the window wipers might not go. So I started taking a 360-degree approach as to how do we create an environment within ourselves that leverages what we know around the pathways associated with aging to tap the brakes and slow things down. So that's been my focus. And we've done a really interesting job in terms of developing products that support healthy DNA, support mitochondrial energy, and also support healthy cellular housekeeping, which are kind of the three top things that you need to consider for healthy aging. And right now, what we're doing is working with one of the world's leading AI drug discovery companies to point their algorithms at these pathways to see if there are other natural ingredients which actually can improve and optimize what we've developed. So we've got some next generation products coming, hopefully by the end of this year. We're just going through testing at the moment. But the idea here is just to really develop products that help people age better. And as a company with a mission, our mission really is to encourage people to think about how they're aging and challenge them to do it better.
Well, Greg, I think that's a great note to finish on, and thank you so much for joining us today and sharing your knowledge and wisdom with us. We'll have links, of course, to your site there, and thank you for joining me.
Not at all. Thank you very much, Ron. I appreciate the opportunity.
Well, when you get down to the cellular level, as I said, it's not hard to see why it's so much easier, particularly if your appointment is just 10 or 15 minutes, to reach for a prescription pad and for the patient and the doctor to feel they're really doing something. But what goes wrong in the cell, and I think it's interesting that the 12th system, the 11 body systems are including nerves and muscles and circulation, digestive, and all those other systems, but the cellular system cuts across all of those, and it's the cells that go wrong, and then the systems start to fail. But it's, I think, entirely appropriate that the cellular system be that 12th system. NAD, which Greg mentioned, just so that you know, nicotinamide adenine dinucleotide is an essential pyridine nucleotide that serves as an essential cofactor and substrate for a number of critical cellular processes, including oxidative phosphorylation and ATP production. That's all about mitochondria. DNA repair, and we talked about that, epigenetically modulated gene expression and intercellular function, and calcium in particular. So NAD, its connection with vitamin B3, nicotinamide. There are two forms of vitamin B3, nicotinamide and niacin, and niacin's the one that gives you the red flush. These are all connected, and when you look at the processes in the cell, the electron transport chain, or Krebs cycle, you will note, if you ever Google that and look at the pathways, you'll notice a lot of supplements and minerals, a lot of vitamins and minerals are an integral part of maintaining that function. Now, you will find also that chemicals and heavy metals interfere with those pathways, but you will also note that there is nowhere in that pathway that there is a need for statins or for anti-inflammatories or for this or for that. So they try to block certain pathways, and that's how they work. So this idea of using supplements is an interesting one, a challenging one, and I often grapple with that myself, and I am reminded that in Australia at least, soils are deficient we have ancient soils and they are deficient in magnesium, selenium and zinc. That's just a given. But as Greg alluded to, if you use chemicals and fertilizers and you provide a plant with those, which might just be 2 or 3 supplements or fertilizing chemicals, then the plant will produce and look good in the supermarket. But if we create healthy soils with a healthy microbiome in those soils, then the soils start to release all of those trace elements that are such an important part of us maintaining our health. So while plants may look good on fertilizers, in healthy soils, we end up with plants that deliver us with 30, 40 or 50 chemicals that are really essential to health. So there's a challenge in the soils that we grow our food in. There's a challenge in the fact that we have environmental toxins that require some support, but it is very nuanced, and I believe it's always good to work with a functional medicine or naturopath, medical practitioner or naturopath to determine what supplements are appropriate to you. That's really important. Anyway, I hope this finds you well. We'll have links to Greg's site on our show notes, as I mentioned. I would also encourage you to join our Unstress Health community, become a member, see curated best of our podcasts, webinars, live Q&As, and a whole range of other resources. Until next time, this is Dr. Ron Ehrlich. Be well. This podcast provides general information and discussion about medicine, health and related subjects. The content is not intended and should not be construed as medical advice or as a substitute for care by a qualified medical practitioner. If you or any other person has a medical concern, he or she should consult with an appropriately qualified medical practitioner. Guests who speak in this podcast express their own opinions, experiences and conclusions.